All right, this is section 4.5, properties of logarithms. Sometimes I call these the laws of logs. Nice alliteration. All right, we have 3. If you have m times n logarithm, I'm just going to leave off what base it is, which I suppose means it's base 10, but it can be any base as long as it's an appropriate number there. So say it's a number greater than 1. Then if you have multiplication as your input of the logarithm, you can break that up into log m and log n, but instead of having multiplication outside, you have addition, which is not really what you'd expect right off by looking at it. But essentially what it is logarithms are the exponents. They're the exponents, and when you multiply two terms that have exponents, what do? You add the exponents, and so that's why we're adding over here, because you add exponents. And here, when you have a quotient, you have log m minus log n. And if you have a exponent, here I'll write this to the k power, m to the k, then this becomes k log m. So let's just jump in with some examples. And this, what we're going to do is we're going to expand. So I don't know, it's sort of fun, not so bad. So let's look at a. If I have log, say, base 2 of 3 times x, what you can write this as is log base 2 of 3 plus, not multiply, log base 2 of x. This is just a very handy little trick that you can use often. And what happens is that often what we do is we introduce logarithms into an equation just so we can use these properties. All right, so here I have 2 terms. When you have 2 terms that are 2 factors you're multiplying, then when you break it up, you add. But it also will work if you had 3 terms. So you could prove that by induction, I suppose. But so you get that. Now let's look at something where I have, say, x plus 1 divided by x plus 2. So this is going to be log x plus 1, and since it's division, it's going to be the minus log x plus 2. All right, now I'm going to do one that maybe is a little tricky here. All right, so ln is logarithm, but the base is e, and e is a number, Euler's number. It's between 2 and 3, around 2.7. Okay, let's look at this one, x divided by y times z. Now what you can do is you can break this into ln x minus ln yz. So I'm grouping the y and z, and I'm using that quotient where I'm dividing those and become subtraction. Now the thing is that we can go further and break up ln yz, and so I'll put parentheses, and that becomes ln y plus ln z. And so this becomes ln x minus ln y minus ln z. The rule is, though, instead of doing all these steps, is that if it's in the denominator, when you break it up, it gets a minus in front. So ln y gets a minus and ln z gets a minus. So let's look at next one, something that has a power here, ln x to the 5th. What happens is that 5 just comes to the front and becomes 5 ln x. Let's try out, say, ln square root of x. Well, this can be considered as ln x to the 1/2, and so this is 1/2 ln x. And throughout, I'm assuming that these expressions are in the domain of logarithm, the expression that we're putting into these. Let's put a problem that's a little more involved. So that was f. Let's look at g. If I have ln, and my goal is to expand this. So if I have ln x plus 1 to the 3rd power divided by x to the 4th times square root of x plus 2. Okay, what I'm going to do to expand this is break this up, each of these factors up, and I'm first going to do that. Now, everything in the numerator gets a plus in front, everything in the denominator gets a minus in front. And I'm going to write x plus 2 square root as x plus 2 to the half. Then the next step is to bring those exponents out in front. All right, there we go.